In order to melt steel, we need to heat the steel to its melting temperature, which is around 2500 to 2800 degrees Fahrenheit. An efficient way of doing this is by using an electric arc, which can reach temperatures in excess of 6500 degrees Fahrenheit. Modern arc welding power supplies will use a transformer or inverter to convert the moderate voltage and moderate amperage mains power provided by the utility company into high current, low voltage power suitable for welding. For shielded metal arc, we use constant current power supplies which deliver a set and maintained current to melt the consumable covered electrode during welding. Voltage is a byproduct of arc length and varies slightly throughout welding with a constant current power supply. Constant current power supplies work by having open circuit voltage available at the electrode once the machine is powered on. Whenever handling shielded metal arc welding equipment that has been powered on, you must wear gloves to protect yourself from receiving an electrical shock. To draw an arc, the electrode is grounded to the base material with a match strike or tapping motion. In order to maintain the arc, the welder must feed the electrode into the base material as the electrode is consumed and transferred into the weld pool. As arc length is decreased, eventually the electrode will short to the base material and the electrode will stick. Short arc lengths result in narrow weld beads with high buildup. As arc length is increased, the arc will become more sporadic, resulting in more spatter and a wider, flatter weld bead profile. Never lay an electrode down with an electrode clamped in the holder. The electrode may touch a part of the grounded table and draw an arc.